What is up, guys? Today we're going to talk about volumes of prisms and cylinders. We're going to start with the bellwork. So the bellwork says the solid cylinder below has a height of 15 centimeters and a radius of base of 3 centimeters. Determine the total surface area. So remember, with surface area, we're just coming up with the different parts that actually make up the total three-dimensional shape. So we have two circles. And we also have a rectangle. Let's go ahead and draw that. So we have two circles and a rectangle. So we just need to find the areas of both the two circles and the rectangle. So our two circles, their area is going to be 2 times the area of one circle. And the area of a circle is pi r squared. So that'd be pi times. And we said that the radius of the base is 3 centimeters. So our radius is going to be 3, so it's pi 3 squared. Well, that's just going to be 9 times 2, so that's going to be 18 pi. Now we just need the area of the one rectangle. The area of a rectangle is length times width. Well, it says the height is 15. So if the height of our objects is 15, that means the height of our rectangle is also 15. Now the length of this is going to be the circumference of the circle. And the circle would be 2 pi r, where that r is actually that 3. So it's 2 times pi times 3, which is 6 pi. So our rectangle is going to be 15 times 6 pi. Well, that's going to come out to 90 pi. So when we add these both things together, we have our surface area is going to equal 18 pi plus that 90 pi is going to equal 108 pi. Now we look to see if there's units. There is units, so we'll go centimeters squared. 108 pi centimeters squared. That is our bellwork. So yesterday we talked about, or today really, if you're watching the video today, we talked about surface area. Today we're going to talk about volume. So surface area was, in a sense, just what was on the surface. What kind of paint would it take to cover it? What is the area of the parts that make it up? Volume is everything inside the shape. So if we look at this first drawing, when we talk about volume, a lot of times we talk about length times width times height. That is basically how many of these little squares can I fill up that entire cube with. So we're not just talking about on the surface like this. I'm actually talking about how many cubes can actually fit inside of that shape. So length times width times height works great if you have a cube, a box, or something like that. However, when we get to different shapes, like A and B, we can't really do length times width times height, especially with a cylinder like this, because you can't put a bunch of cubes in it. For that, problems like that, we're going to focus more on using this idea of volume. That we can look at volume as just calculating the area of a base. So we calculate the area of one base. And then to construct our figure, we're going to count how many of those bases we actually have. And that's going to be a multiplication of that base times the height. So we're going to keep drawing base after base after base until we fill this whole figure up, which is just the area of the base times the height. And that's what we have down here at the bottom. Let me make that a little bigger eraser. So that's what we have down on the bottom. We have volume equals the area of the base times how high that figure is. That's going to calculate the entire area. So think of it as like plywood sheets that you keep stacking them up on top of each other. You just got to figure out how many of those plywood sheets you need to actually construct that rectangle, that cylinder, that cone, or what have you that you're working on. So our first example, well, we could on this one, we could, finish this off, make this into an actual cube, do length times width times base, and subtract out that little section. But instead, I'm going to use that second method where I just have to come up with the base and then how high it is. So let's go ahead and draw the base. So I'm looking at that base as kind of that L-shape object that's there. So let's go ahead and draw that. So I'm looking at a shape that looks something like, probably not perfect to scale, but something like that. All right, where our side here is 9, this length is 5. I'm actually going to move that 5 underneath because I want that space. That 5 goes right here. We also have an 8 here. Notice on the bottom, but it will also work for the top because our base is the same as our top. And then we also have this is 3 here. Well, if this is 3 and this is 9, that means we can get this length here. It'll just be 9 minus 3, which will be 6. All right, and since this length is 5 here, if I just extend this line right here, this is also 5. So the area of this box right here is just 5 times 6, which is going to be 30. That is the area inside that box. Now, the other rectangle right here would be 9 times 8. Well, 9 times 8 would give me 72. So our total area of our base or our top, or whatever we want to call it, is going to equal 102 centimeters squared. So that's the area of our base. Now recall, what we're trying to do is we're trying to take that base and we're just going to keep stacking it over and over and over again, and calculating how many times we have to do that. We just have to multiply it by the height. So once again, our volume is going to equal the area of the base. Now, let me shift that down just a little bit so I don't run out of room. Is going to be the area of the base times the height. Well, we now have the area of the base as being 102, so we'll fill that in. 102 times our height is 20 is going to equal 2,040 centimeters cubed. Let me rewrite that so it's a little clearer. 240 centimeters cubed. Now we have to say cube because we're taking into account for 3 dimensions, right? A volume is cubed. It's got 3 different things. It's got length, it's got width, and it has height. So that's why we have that 3 there. Area was squared because it had length and width. Volume, we're adding 1 more dimension to it. So we have 3 dimensions, so we need centimeters cubed. All right, for a cylinder, well, the nice thing about this as opposed to surface area is I really just care about the base and the height. Well, the base is just a circle. Let's draw that circle. It's a circle with a radius of 14. So the base I'm talking about is just going to be the area of this circle. Well, that area just equals pi times r squared, which would be 14 squared, which is going to equal 196 pi. So that's the area. And since our volume equals the area of our base, we now have 196 pi. Multiply it by the height. Well, the height was that 27. That's my height. So it's times 27, which is going to equal 5,292 pi centimeters cubed. Now I know I don't have the centimeters on here, but I just want to treat it like it's centimeters just in case we have those as part of the problem. All right, this next shape, this is kind of like half or a chunk taken out of pie of sorts. Well, this would probably be a lot of work if I was doing surface area, but the good thing is volume's, I think, a little bit easier than surface area. Because like I said, you just have to find your base, figure out what the area is of that base, and multiply by our height. So looking at this, I already know my height is 10. So we already have that. Now I just need the area of my base. So the base is going to be a little Pac-Man looking face. Let's see if I can draw that. Not the best, but it'll work. Where we have a radius of 6. Now it says inside of here is 100 degrees. But I'm not too concerned about that 100 degrees. I'm more concerned with the fact that it's 260 degrees is the actual measure of this. Because now when I do my area, Our area is the area of the circle and how much percent of the circle I'm actually using on it. So the area of a circle is pi r squared. So we know we're going to have to use pi r squared. Well, our r is 6, so it would be pi times 6 squared. But I have to do a percent or a ratio out front. Well, that ratio is 260. That's a 3. 260 divided by 360. That will give me the percent of the circle I'm talking about. Well, if we do that math, we're going to come up with 26 pi. So that is the area of our base. Our volume is just our area, which is 26 pi, times our height, which is 10, times 10, which is going to equal 260 pi. And let's assume I said centimeters to begin with, so we can get in practice of going centimeters cubed. Our next one looks like we have a triangle type prism. Now when we talk about base, if you look at the one before it, the base is either we're talking about the top or we're talking about the bottom, and we're stacking it up or down. Well, base doesn't have to necessarily be on the bottom or the top, because if we consider this rectangle, if I would call this rectangle my base, and I would stack that over and over and over again, I would lose that triangular shape that I wanted to end up with just a rectangle. So that would not be the base I'm talking about. Instead, I'm talking about my base being this triangle right here. Because now we can kind of picture it being stacked over and over and over, and I can actually make that shape. So we have to remember, and it's sometimes a struggle, but we have to recognize what shape is being repeated over and over and over. And in this case, we're talking about this triangle here. So I need to get the area of that triangle there in order to get my volume. So let's go ahead and redraw that triangle. Let's redraw that triangle. Oh, that's terrible. Let's make this a little longer. All right, there we go. Now we have our triangle here, where I know this is 8. I know this is what I'm looking for because I need base times height, but I also have the hypotenuse, which is 17. So I'm actually looking for this x. I'm looking for this x right here because that will be, because our triangle's area is half the base times the height, I do need that x as the height or the base. So in order to do that, we have a right triangle. I have two sides. I can just use the Pythagorean theorem, so no need to look for degrees or anything. So we'd have 17 squared equals 8 squared equals plus x squared. I would subtract 8 squared from both sides, so we'd actually have 17 squared minus 8 squared equals x squared. When we do that math, we should come out to x equals 15. And that is because 17 squared minus 8 squared, you should get out to 25. All right, cool. So that's the area, or that's not my area, that's just my x right here. So the next thing we're going to do is we're going to get the area of the base, and I'm going to go ahead and do that here. So that would be the area of that triangle is going to equal 1/2 our base times our height. So that's 8 times 15. Well, that's really just 4 times 15, which is going to come out to being 60. So 60 is the area of my base. So to get our volume, let's come down here. Our volume is just the area of our base, which happens to be 60. And we're going to multiply it by our height, which is going to be actually that 21. Since my triangle is my base, my height must be going that direction. So it has to be that 21 and not that 8. So once again, it's the area of that triangle times the height. And so that's the direction I'd keep stacking it. So that would be that 21. So we have 60 times 21 is going to equal 1260 centimeters cubed. All right, so I think the long and short of this is, although length times width times height works great for rectangular or box types objects, pretty much everything else, we are just going to do the area of the base times the height. And in fact, that's exactly what, if we actually look at what's happening here, that is the area of the base times the height, because we do length times width, which is the area of our base, and we're just multiplying by the height. So regardless of what formula we're using, it really is the same thing. So rather than thinking of length times width times height, I always think of just area of the base times the height. It just makes it a lot easier going forward with different types of shapes. Speaking of types of shapes, once again, I'm going to have some more pictures of prisms because you do have to draw some pictures in this homework. So when we're talking about prisms, these are the types of shapes we're looking at. And for cylinders, these are the types of cylinders we're looking at. I do like the horizontal cylinder because that also gives us a good picture of our base wouldn't be on the bottom, it would actually be on the side here. That would be my base, and my height would be going that direction. So just recall that base doesn't have to be on the bottom or top. It could be on your left and right. Just ask yourself, when I stack it, would it make the entire shape if I just kept doing that same shape over and over and over and over again? All right, that is about it for volume. Volume really just takes practice on the different types of shapes. So when we go through this homework, you're going to notice that your whole goal is really just to come up with what is your base, find that area, because height is pretty easy after that. All right, everyone, good luck. I will see you on Monday for any questions on either homework 12.1 or 12.2, both of which will be due on Monday.